I'm going to hit the record button now that we're mostly all here, that it's going to come. And I think most people turned in an assignment for 1A. There's maybe like a handful of people that like either didn't turn something in or were like a little bit off on what they should have been doing. But I think most of you got it in. I don't want to play music. I'm going to exit that option. And that thing's connected. And I started recording. And so now I need to share my screen. He's talking to himself. He's losing it. Okay, so here's my quizzes. Join up, join up. I guess I could copy and paste this in the chat there, probably, huh? Where's the bar? Come on, bar. Oh, paste that there, everyone. I think. I hope this works. If not, I'm gonna have to reconnect my phone a different way. I think this works better though than the other way. Put it over there. There we go. All right, I think that's everyone that's here, maybe. How many participants did I have today? No, there's 2 people. Where y'all at? Because I fall asleep already. It's too early to fall asleep. I'm not allowed till at least a few more minutes in. Okay. Yeah, so this is also the homework. This is from the selected problems from the book. All right, ready? I turned off the sound effects, so now I gotta provide them. Oh, turn off the timer. Okay. Determine whether the following statements are propositions and given explanations. So I know it says true or false, but what it really means is true, it is a proposition, or false, it is not a proposition. So it's not asking whether the statement is true or false. Just to verify that. It's asking whether or not it is a proposition. We are in here from 3 to 4:20 today. That's what it goes from. Ooh, one more person. Come on. Ah, it's a 50-50 shot. Come on. I don't want to hit this button. Don't make me hit the button. I'm gonna hit the button. So is this a proposition? What are we saying? Is the sky is a limit a proposition? So why is it a proposition? Why is it not a proposition?
Because it's stating something.
Yeah, it's stating something. The sky is the limit. Can you verify whether or not the sky is the limit? If you go above the sky, then it obviously wasn't, right? So it is something that is kind of verifiable, right? It's something that you can declare as true or false. If our plane doesn't fly above the sky, then obviously the sky is going to be our limit. What is this? Something commanding something. What did it say? Gotta look. Back to the Future. Great Scott. Okay. There's an old SNL skit with Michael J. Fox where he's in an elevator and they're just like they're humming that song. Gonna go back in time. Just like they just keep humming that one part over and over to the point of where it's just like it's just really annoying. And you're by the end of the by the end of the skit, I think you're almost equally as annoyed as Michael J. Fox is in the skit. Oh, come on in. All right, so there's one person that keeps sleeping on the question. It's a button. You click one or the other. So is this a proposition? Why or why not? So I think most people are getting it. There's a handful of people. So why is this not a proposition? Back to the Future, is that stating any sort of claim?
No, it's not really saying anything. It's just like words.
It's just a title. It's just like saying future. It's just a concept, right? Yeah, it might be a command. Maybe if you're telling someone to go back to the future, that's a good observation. I thought I was going to disable those stupid little noises, but I guess not. Write the negation of the given proposition. So what does it mean to negate something? If I negate what you're saying, it's like I'm like contradicting it, right? It's like the opposite, right? So is this the Beatles one? The Beatles were not a German band. So what is the negation of that? And this one, I think it does grade this one.
Is it not showing up on anyone else's screen? Is that just me?
So if you click like the back button and get out of your little keyboard, it might pop up at the bottom. But it says the Beatles were not a German band, I think is what the original one says, right?
Are we just writing true or false?
This is not a true or false. They want you to write the negation. So we want to write the opposite of that.
Oops. No, I'll make it up for next time.
So 8 people left. Probably 7 people that are still awake. Ooh, 6 people that are still awake. We're at like 5 people away. So how do I negate the Beatles were not a German band?
Don't you just say like the opposite of what it is? If it says they're not a German band, didn't you just say that they were a German band?
That's exactly what you do.
They just take the not out.
You just take the not out. You should, well, technically, if we're like being like really like kind of sticklers about things, I think if you're negating things, typically what they do, and if you get into like symbolic logic and stuff, they will say it is not the case. They will like use that little preface thing. The Beatles were a German band would be the negation of it. It is not the case that the Beatles were not a German band. But if you said that in real life, someone would get really mad at you probably, right? And so really like you want to simplify it, since it's a double negation, what you're saying is actually the positive, right? So the Beatles were a German band. Oh, come on, connection. Where's this going at? Okay, so I think we wanted to write, oh, sorry, yeah. This one is broken up into writing the negation, and then the next part, I broke up the true and false parts. Sorry, I broke this question up into like 3 parts. So now we have the original statement, which was the Beatles were not a German band. Is that true or false? I probably broke this one up to which? I'll give you a hint. The Beatles were part of the British invasion. And I'm not good at geography, but yeah, I think you should probably know that one. So the Beatles were not a German band. Does that sound true or false? It's a 50-50 shot. Are there 2 people asleep now? I gotta look at y'all's names if I really wanted to be a jerk. Ooh. Okay. I think that's it. It is true the Beatles are not a German band. They are from Great Britain. That is not German. And then the next thing, if we wanted to negate the Beatles were not a German band, the original statement was true, so its negation has to be what? The Beatles were a German band. Is that true or not? I should have probably just left that timer on there. It's a 50-50 shot. All right, that's it. Let's go. All right. Seems like a few people. The Beatles were a German band. Is that statement is definitely false. They are from Great Britain. Are there questions about this? Why this is a false statement? Do y'all understand why that is not true? Sprechen Sie Deutsch? No? Okay. I'm glad because I don't speak very much. Okay. Multiple negations. So now, what are we doing? Sarah did not decline the offer to go to dinner. So again, this is getting at the what? The double negative sort of thing. So does that mean she went to dinner or did not go to dinner? Okay. We're there. What was it say? So she definitely went to dinner. This is a double negative. If she didn't decline, what did it say? She did not decline. And that means she went. Two negatives makes it positive. And we doing and statements. Okay, so there are 5 parts to this thing that we need to write in here. So we need to know what P is. We need to know what Q is. So this is 2 propositions connected by and statement. So P is your first proposition. Q is your second proposition. And then after you say what P and Q are, then you need to say whether P is true. You need to say whether Q is true. And then we need to determine whether P and Q are true. So someone said, P is dogs are animals. So the statement is dogs are animals and oak trees are plants. Oh, why are you going to do this to me? They said you didn't pay nothing. All right, and then Q is oak trees are plants. So is P true? That's the next question. Are dogs animals? Does someone have a response to that in there? I can scroll down and see too, I guess. P is true, Q is true. And then if we put them together, if we have something that is true and true, what are they together? They are going to both be true. So I think I'm seeing a few people answering that. All right, I think I'm going to hit the end question really, really slowly. But I think we've covered our bases on this one pretty much. If there's any questions, you can always speak up. Let me know. And if you talk, if you get the courage to just speak up and talk, I'll actually probably see it faster than if you type. But I'll try to answer both. Okay. So what do we say? P is dogs are animals. Q is oak trees are plants. And we know that dogs are animals is true. We know that oak trees are plants. That is true. And if we put these together, dogs are animals and oak trees are plants, that statement is also true. This, okay, that might help. All right, so this is another and statement. I think they want the same thing. I think it's the same format, if I do recall. I don't like what the book said, but okay. P and Q. So we got to figure out what P is. We got to figure out what Q is. So this says all birds can fly and some fish live in trees. I don't know where this D is coming from. Should be P is all birds can fly. Show me your responses. Q is some fish live in trees. What about P? All birds can fly. Is that a true statement or not? So we want to look at them first separately. And I don't like the book. I copied the book's answers, to be honest, and I didn't really pay that much attention. And then I really thought about it, and the book is not correct on this one, I don't think. So the book said all birds can fly. They said that was true, which is not true. There are flightless birds. Q is some fish live in trees. That is also false. I feel like that might be more true than the first one. Some fish live in the roots of trees. I mean, that's kind of what are we considering the tree, right? But for the most part, I would probably say P is false, Q is false. And if we put them together, guess what we're going to get? A false statement. All right, so the book didn't say that. They said P was true and Q was false. So if we put a true and a false together, what do we get? Did someone say it in the chat? Yes, if you put a true and a false together, you still get a false. So in order for things to be true with an and statement, like everything has to be true. And is really demanding, it's really strict. Like I want a pony and a Lamborghini and a new apartment, a new mansion. I can dream bigger. Okay. So this is what the book said. I don't agree with P, but there it is. All birds can fly should be false. Fish live in trees, probably not for the most part. P and Q, if we put them together, it is still going to be overall false. Okay, so now we want to make a truth table. So now I have to flip here, and we want to do Q and R and S. So let me stop sharing this thing. Stop share. Let me swap my video. That's not what I want to do. Can y'all see my screen, hopefully?
Yep.
All right.
Yes.
That looks blurry. I think I might have to do some autofocusing a little bit, maybe. There we go. So we want to do Q, R, and S. Do y'all remember? If Q is a proposition, how many different options am I going to have for a proposition? It's either true or false. So I'm going to have 2 for this. I'm going to have what? 2 for this. And I'm going to have 2 for this. Did I talk about that like counting principle? I don't remember if I did or not. How many different options am I going to have if I have 3 different propositions?
$24.
Ooh, that's a little high.
8.
All right. So this is basically how you can do it. There are 2 options here. There are 2 options here. There are 2 options here. So you should have 2 by 2 by 2, which gives me, someone said it, should give me 8 options. This goes back to like there's this thing called, I think it's called the simple counting principle, is what they call it sometimes. Oh, the other way. I have 2 roads going from like this city to this city, and I have 3 roads going from this city to this city. How many unique routes can you drive from like this city to this city, right? And if you look at it, I can drive this first road, and then there's like 3 different routes. I can drive the second road, and then there's 3 different routes there. Think about it. What you're doing is the total number of options, and you're just multiplying them. So if there's 2 options here and there's 3 options here, I get the total number of options just by multiplying those things. When I was working in high school, I worked at Whataburger, and for like the longest time they had, I don't remember the exact number, but there are so many different ways to get your Whataburger, and they had the exact number. And people, it kind of amuses me a little bit because people are like, they must have got some kind of math whiz to like figure that thing out. And it's like, literally, like all you have to do is like for each option, like whether it's like ketchup, mustard, pickles, onions, all you're doing is multiplying by 2 a bunch of times, whether or not you put the thing on the burger, right? Does my burger have ketchup or not? For each option. So this is going to be 2 times 2 times 2, right? Is that what we're going to look at? If you have what, 2 propositions, how many options should you get? We're going to do 2 propositions in a minute. 4. There we go. All right, so there are a few different ways to kind of get at this, but we want to have every possible combinations of trues and falses that Q, R, and S can be. So the way I really like to start is to start with all trues, and I think most people kind of, they do this at least. They start with all trues and end with all falses. So we know we should have 8 different options. So if in the end we count something and we're like missing something, we can always try to adjust something. I guess technically it's correct even if it's not out of order, but it's just like, it's just so much easier. What I do is I start with one false and then I kind of try to do everything that would have one. And now I do what? 2 falses. And one false. And now I think about everything that would have 2 falses. And now I let this guy dance to the left side. False. 2 false. He's all the way over. Now it's this guy's turn. False, false. True. And then I think that gives me 7. I think my last one now is false, false, false. Is that 3, 6, 8? That should be all. That's it. Okay. I think this is probably about as complicated as one as we're gonna make you. Like do it with 3 propositions, because we're already at what, 8 options. If we go to 4, we're already at what, 16 options. If we go to 5 propositions, we're at 32 options. Do you really want to write 32 lines in a truth table? I don't think so. Like that's an essay right there, right? I'm not trying to make you write an essay in a truth table. So Q and R and S. This is a really big sort of table, but it should be, hopefully, if you understand what's going on, it should be kind of easy to fill out. This true and true and true. If we know everything is true, this could be like what? The grass is green, the sky is blue, and the sidewalk is gray. I don't know, something. You can come up with sentences to throw in here if you want. And if we look outside and the grass is green and the sky is blue and the sidewalk is gray, is it true the grass is green and the sky is blue and the sidewalk is gray? Someone answering this? If they're all true, is the conjunction, the and statement true? T, someone said T. Overall, it should be true. If each one is true, then overall, this and statement is true. What about the next one? If we look at the next one, if I say the sky is blue, the grass is green, and the sidewalk is gray, and I look outside and the sidewalk is not gray, someone painted it red, I don't know. If it's false that the sidewalk is not gray, is it true about all 3 of these things? If I put them together? No, okay.
Is it false?
Yeah, it is false. And if the grass is not green, are they true overall? All right. So how should I fill out the rest of this table? I'm just going to ask that. I think it's probably the easiest way.
It'll just be false.
It's all false. If one thing is false, guess what? Overall, the sentence is false, right? If 2 things are false, then it's definitely false. So everything else should be false. If one of those things ain't met, then overall, if we put them together, the thing together is not going to be met, right? That's what we mean with and. Everything has to be true for an and statement to be true. It is really demanding. If one of those things doesn't match up, ain't no good. Any questions about this? I think, did I skip over one? I felt like there was one or two, but maybe it's like coming up, I think is what's happening. Okay. I'm going to go back to the quizzes. So let's go back to the quizzes. We did Q, R, and S. And that is what, 37. Ding, 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 ding. Now, what does it say? Interpreting or statements. I think this is where we do the 1 and 2 propositions. State whether or is inclusive or exclusive in the following propositions. So exclusive means, I can't get my way. Inclusive means it's okay to do both, that you mean that you can do both. Exclusive means you're going to do one or the other, but not both of them. That's probably the way without just giving the words away. There are two words. There's one word in here. The or statement. The or word is one of the words, but there's two words that really tell you what sort of or it is. There's one word that really tells you what sort of or it is. There's two important words. One of them's or, is what I'm trying to say. My puppet's snoring. All right. This is a 50-50 shot. So what are we saying? Either and or. Yep, that's the words. Either or. Either or really represents which one of those things. We're about to see it as soon as I end this. Either or means I'm going to do one or the other, but not both. If I say I want to do either this or that, it means I'm going to do one or the other, but not both. The next one, I believe, is the vacation one, if I remember correctly. Is that the next problem? I would like to scuba dive or surf on my next vacation. So would it be okay to do both of those, or do you want to do one or the other, but not both? And this one, I don't know. I know where the book's going with it. But if I'm being honest, I could see why you might think it's the other one. Where are we at? So if it's okay to do both, then we call that inclusive. If you don't want both, then we call that exclusive. And I talked a little bit about this in the notes, but like, how do you know whether it's one or the other? It's kind of context, right? You have to read the context. Is it okay to do both, or do you mean one or the other and not both? So in like everyday language, we are not precise with how we use the word or. In logic, we mean the inclusive or. Like almost every time we use it in logic or math, when we use the word or, we mean it inclusively. So this one, that when they were talking about vacation, they said we could either skydive or scuba dive, I think is what it was. This one, the book says it's inclusive, so it's okay to do both. Typically when people say that, they usually mean they have a budget to do one or the other. So I could see it maybe if you thought the guy had a budget and he wasn't trying to do both of them. I can kind of see it maybe being exclusive then. I think in my notes, what was my example? You have to get 350 on your TSI or you have to pass a prerequisite. That would be the inclusive, right? It's okay to do both of those. You could score 350 on your TSI and get the prerequisite class, and you'd still be able to get into the class. The exclusive, if I want one or the other, the example I kind of gave in the notes was like the mugger example, right? Give me your money or I'm stabbing. It means one or the other. You don't want them to do both. Okay, so what's the next problem? Is this another truth table? R or S? It is another truth table. So let's stop sharing here and let's go back to the screen and flop it on up in the carrier. R or S? So I gotta do R, I gotta do S. I gotta do R or S. Get on up there, boys. So how many different options do I have here? This one I feel like you could probably figure out. Yep, 4 options. So we start with all trues. We're going to end with all falses. You do this, you already have half your options down there. And then there's just 2 more things in the middle. I feel like this one almost fills out itself. What's happening here? We can have a false there, or we can have a false there. Or statements. So what does my table for the or statement look like? That's the next question. If I have something that is true or true overall, what is that going to be? So this is like, and this is inclusive, right? Sorry. Not specified, what we mean is, and so if we're talking about inclusive or, this is what we mean by inclusive. If it's both true, so this is like I scored 350 on my TSI or I passed a prerequisite. If you did both of those things, did you score 350 on your TSI or pass your prerequisite? You absolutely did. You did both of them. And this is getting back to that inclusive thing. Sorry, I probably should have specified it's the inclusive one. If it was the exclusive, this one would be false here, right? That's how they differ, is that first little step. And what about the next one?
False.
So this is basically saying the requirements for the class, right? So if you scored a 350 on your TSI, are you going to get into the class? Someone is starting to speak up. I think I might have cut you off. I'm sorry. But that's what, true? That's what someone's saying in the chat. Getting some T's up in here. If you, what is this now? Pass the prerequisite class, are you going to get into the class? You should get into the class, right? If you did not score on your TSI and you did not pass your prerequisite, are you getting into the class? You are not getting into the class. Okay, so what can we say about or statements and like the way they sort of look and their truth tables look? But like, what's sort of like a rule? Like, what is like an easy sort of way to think about this? And is really strict, right? And so for an and statement, everything has to be true. For an or statement, how many things have to be true? One. We just need one truth in there somewhere, right? As long as we got one truth, the overall or statement's going to be true. So or is not really picky. It's like you got to do one of these things, bro. Right? And is like I want everything. It's really demanding. So hopefully it makes a little bit of sense with like how we use these in our language a little bit. Any questions about this? Okay. You gotta stay hydrated. All right, so now I want to go back. I want to go back to my quizzes. Let's go back to the quizzes. Oh, I gotta put it in my phone. Okay. Phew. All right, so that is the R or S truth table. Oh man, I shouldn't. Got to do P, Q, or R now. Okay. So I'm gonna exit out of this again. Not exit out of this. Stop share. That's what I want to do. P, Q, R. And now we gotta go P, Q, or R. So I want y'all to get a little maybe ahead of me on this one. P or Q. Or Q or R. or. Start sounding like a seal. Okay. PQR. So I want to start out with true. Okay. Now I want y'all to give it a go. Try to fill this thing out. Try to fill out this entire thing with all the different possibilities. Hopefully you remember how many different possibilities there are. If not, you can always look back. But try to fill that out. Try to fill this thing out based on what you know about or statements. I'm going to give y'all just a minute to do that. I'll be right back. Okay, we have all truths. We want to do all the ones on the right. That will give me 3 more. I think that gives me 4. Now I got to do the ones with 2 falses. Just enough at the bottom of my paper, I think. Okay, so what does this truth table look like over here? P or Q or R. If it's true or true or true, what is this overall?
True.
This one's true. If it's true and false, what is the or statement overall?
Also true.
Yeah, this is also true. And so what does this thing look like? Is there a way you can describe this table? What's the last one going to be? The last one's false, right? What about the one above it?
It's kind of like what we did on number 37, except the opposite, whereas in all of those were false except for the one that was all true, since this one is inclusive.
Mhm.
All of them are going to be true except for the row that's all false.
Exactly. Exactly. Did you hear that? So the row that's all false, that's the one that's false. As long as we have one truth, right? All these up here have at least one truth in them, right? As long as we're doing the inclusive OR, which we usually do. All these are true except for the one where they're all false. So this is kind of the I guess the mirror image of the other one, right? Or kind of the opposite, not really the mirror. Kind of the opposite. Questions about this? Okay. So let's go back. Quizzes is 16. How many slides are on this thing? Okay. On my phone. Or statements. So now we're going to have or statements that I think we have to break down in similar ways that we did before with the and statements. So what is my P? What is my P proposition? What is my Q proposition? Is P true? Is Q true? Is P or Q true or false? So P is that first thing that they say there. Elephants are animals or elephants are plants. So P is the elephants are animal statements. Q is the animals are plant statements. So P is obviously true. Q is false. But now what about P or Q? If we put them both together, if we say this thing is a whole statement, elephants are animals or elephants are plants, is that or statement true or false? So we want to talk about putting the or statement together. And you might want to go back and look at that truth table, right? That might help you if you look at maybe the second line of that truth table with the one or two propositions, right? In your NOR statement. If we put them together and the first one is true and the second one is false, what does that make it overall? It is true overall is what we're saying then, right? Okay. Are there questions about that? So this is like kind of like if we go back 28 new responses, how are we getting more than 26 responses? Are they letting y'all go back in? I didn't know that. Okay. So this is the next slide. This is what we were saying. I feel like I talk way too much in class. All right, elephants are animals is P, elephants are plants is Q. Elephants are obviously animals, they are not plants. So P is Q, P is true, Q is false. If we put them together and we look at this statement as a whole, this is a true statement, and it's a true statement mainly because this first thing right here is true, right? Has nothing to do with that other half of that statement. We're just kind of ignoring it. Okay, stop the timer. So now we got another or statement. Oh man, now we're actually getting some numbers in here. It's starting to look a little bit more like math, maybe. 3 times 5 is 15, or 3 plus 5 equals 8. So mind your P's and your Q's. What is my P? What is my Q? Was my P statement true? Is my Q statement true? If I put them together, is the OR statement true? So P is the 3 times 5 equals 15 is the first thing you see there. The Q is the next thing that looks like 3 plus 5 equals 8 is the next thing we see there. It is true that 3 times 5 is equal to 15. It is true that 3 plus 5 is equal to 8. And so if we look at the OR statement, this is getting back to the, hey, we use that inclusive OR in math, right? If they're both true overall, guess what? That makes my OR statement like the first line on that truth table. And it's not on here, but it should say P or Q is true, right? I think it got kicked off or something. So this is my P statement. This is my Q statement. If I look at P, this is true. If I look at Q, that is true. My P or Q is also true. Are there any questions about this? So even if they gave me garbage on one of these, right? The overall statement would still be true as long as one of them is true. Okay, truth tables. Make a truth table for the given statement. Assume that P, Q, and R represent propositions. Okay, so now we got into the truth table. So let's do that. Stop the share and swap on over to this camera. So what was I doing if, what were the variables they gave me? It doesn't really matter too much about what variable you use, right? But they're giving me P and R, so I'll try to keep it consistent with what they're doing. And I hope by this point, hopefully you can fill this thing out before I do for the P and the R, right? And then we want to know if P and R. Did we give you the notation with the little arrow? Sometimes they call this the antecedent and the consequence. So it helps if you think about something that is a what do I say it, like a causal relationship, right? And so I think in the notes I said something like if I flick a switch, then the light turns on, something along those lines, right? So we want this. We want to put every option for P and R. So true, 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 false, true, false, false. There should be 4 different options. So sometimes you will see like P arrow R. That means if P, then R. This is called the conditional statement, right? So if this is something like if I flick the switch, then the light will come on. If I flick the switch and the light comes on, is it true that this is basically saying the light controls the switch, right? If I flick the switch, the light's going to turn on. That's saying the light controls, the switch controls the light. So if I flick the switch and the light comes on, can I determine that the switch operated the light? Yeah, that would be true, right? We could say that the switch is going to operate the light. If we flick it and it comes on, if we flick it and it doesn't come on, can we say that the switch operates the light? We can't say that. We can say it does not, right? So this is the one that's going to be false. And then if we look at the next one, if we don't flip the switch, but the light comes on, can we say the switch operates the light? Someone said true. Why would you say that's true? Do you remember why these are true?
They were vacuously true, I think.
These are the things that are vacuously true. So these are a little bit weird, right? And I'm just being honest. Yeah. So and it's a little weird because we don't meet our antecedent, right? We haven't flicked the switch. So there's no way that we can determine like really whether this is true or false. We kind of give them the benefit of the doubt and like say it's true. It's like, well, we assume the statement's still going to be true. And so this is like we don't flip the switch, but the light still comes on somehow, right? So maybe there's a third switch, maybe there's like a remote or something happening. I don't know. But there's ways that the light could still come on, but the switch was never flipped. And it still doesn't mean that the flip, right? It still doesn't mean whether or not the switch operates the light. Are there questions about these? If we don't flip the switch and the light stays off, can we say anything about the switch operating the light? There's nothing we can really say. We can't determine whether that's true or false, right? And so we kind of assume these things to be true. What's a way you could think about like maybe this truth table that might help you? Because really it's only what? It's false here, right? So if you meet the antecedent, but like the consequence doesn't happen. So if you flip the switch and the light doesn't come on, then we can kind of determine it's false, right? The switch ain't operating the light there. Other than that, we kind of assume if-then statements are true. And these create really sort of weird scenarios when we like start applying this to our linguistics and to reality. But there's reasons, and I think I got at some of the reasons like the Boolean algebra and stuff. There's reasons why we want to kind of assume those things to be true. Questions about this? Okay, I think we might come back, talk a little bit about something if I got a little time. It's 57. Where am I at? Slide. Next slide. There we go. Okay. So this problem says, load on up. Come on. If-then statements. And now we're looking at if-then statements. This is kind of the same thing we were doing earlier. There should be like 5 parts to your solution here. We should have a hypothesis and a conclusion instead of a P and Q statement. So we have an H and a C maybe instead of a P and a Q. If trout can swim, then trout are fish. So you want to identify the hypothesis or the antecedent, and you want to identify the conclusion or the consequence. And then after you identify H and C, why does it not show me responses? I don't like that. Show me them responses, because after you identify the hypothesis and conclusion, then state whether it is true or false. Your hypothesis is true or false. State whether your conclusion is true or false. And then state whether the conditional statement, right? The if-then statement, the overall statement. So the hypothesis is the first part that's there, right? I think that's what y'all are saying. The if trout, ooh. So when you do the hypothesis, don't put the if and then words on there. Leave off your if and then words. So the hypothesis should be trout can swim, not with the if on there, right? And then the conclusion part should be the trout or fish. And so trout can swim is true. trout are fish. That's also a true statement. And so overall, if we have a true and a true, what line is that like? Does it make sense to look at like the little truth table? What line would that be like from the truth table? Yeah, it's like the first line. Okay. I was just trying to make sure you guys are picking up what I'm putting down. Yeah, so it should be like the first line, right? If we have P is true and R is true. If our hypothesis is true and our conclusion is true, overall, if P, then R, if hypothesis, then conclusion. Where am I? In question. There we go. Then overall, right, the if-then statement should be a true statement. So just like that first line of your, of your truth table. So the hypothesis is trout can swim. That's a true statement. The conclusion is trout are fish. That is also a true statement. If we have the conditional, if we take this as a statement, as a whole statement, right? If trout can swim, then trout are fish. That's a true declaration. Again, I think, especially with these if-then statements, thinking about your truth table with these will probably really help you pull through, because some of them are a bit wonky. What are we saying now? If trees can walk, then birds wear wigs. What is my hypothesis there? What is my conclusion there? Is my hypothesis true? Is my conclusion true? Is the conditional statement, if we take that statement overall. Lord of the Rings, that's what I'm reminded of. So boring, even the trees were walking. As long as I make this reference, right, and not the none shall pass, or you should not pass. It's probably not something you want to hear your professor saying. You shall not pass. Trees can walk. Unless we're in Lord of the Rings, that's going to be false. Birds wear wigs. Unless there's some jerk out there gluing them on their heads, that's mostly false. So if we look overall, what is the overall? And what line is this like? Maybe from our truth table. Trees can walk, trees can walk. Let's just see our false. The same as false. Overall. Oh man. What's the overall? If we say if trees can walk, then birds can wear wigs. It's like the last line. And so what's that last line like? So this is the weird vacuously sort of thing, right? I'm glad we're getting it. So what happens if your hypothesis is false? If trees can walk, right? The second I see that this thing is false, what can I say about the overall statement? It's kind of like the second they say something absurd, right? You can just kind of ignore them, and you can tell me the overall statement should be what? I know one person's getting it. Anybody else getting this? It should be true, right? True, true. And this is just like that last line, right? The last line of our truth table. This is true, and it's mainly true right here because the hypothesis is false. Because if we look at trees can walk, this is never going to happen. And so since we can kind of guarantee this is never going to happen, like overall, we can still say that this thing is true. So if trees can walk, then birds wear wigs. That is a true statement. The hypothesis is false, the conclusion is false, the overall statement is true. And even if they gave us something true here, right? What's something true? Birds wear wigs. The sky is blue. If trees can walk, then the sky is blue. Like even if it was true, overall, this would still be a true statement. The only time we can call this a false statement is when we can prove it false, sort of happening, right? I think we might have one like that in a second. Who knows? Let's see. What does it say now? If then statement, we want the same 5 things that we've been looking at, but now we're calling them what? Hypothesis and conclusion. If dogs can swim, then dogs are fish. So what is my hypothesis there? What is my conclusion? Is my hypothesis true? Is my conclusion true? Ooh, ooh, ooh. Stop that. Stop it. No. No. Oh. Let's restart that. Did it restart? What's happening here?
Yes, it restarted. We can answer now.
Okay, but it's not showing me a timer. What's doing it? What is it doing? Okay. What's my hypothesis there? What is my conclusion? Hypothesis is the first thing that I said there, right? Dogs can swim. Conclusion is the second thing that I said there. Dogs are fish. Can dogs swim? Most dogs can swim. Do a little doggy paddle. So I would say for the most part, H is true. C is what? False, that dogs are not fish. Yeah, we're getting there at a time. Okay. So let's go a little bit quicker. So H is true, C is false. If we have something that is true, then false, the overall thing, this is the one sort of like scenario where we can actually say it is false, right? If we can prove it's false, the first thing is true, the second thing is false, the overall thing should be false if we say if then. So this is like the second line that we did. So again, my hypothesis was dogs can swim. My conclusion was dogs are fish. The hypothesis is true, but my conclusion is false. And when we have something like that, the statement if dogs can swim, then dogs are fish is false. And so if, I know I'm like, it sounds like I'm just like saying the same thing over and over again, to be honest, at least to me. But if we think about this, right? I have a dog, it can swim and it is not a fish. I just proved this thing false, right? I just proved this statement false. So I think we're getting close to the end. This is the last slide. Okay. So let's end this lesson. Let's see what we did. There's one little tidbit I'll add you with. If you got to get out of here, it is the end of class, understand. But there's a sort of little interesting little tidbit that we're right there, and I'm gonna talk about it, I think. Where am I at? Here's my phone. So we talked about conditional statements. Did you ever have to, like, in a math class? I remember having to do this. The if and only if. Do you remember writing these things? If you did like theorem, right? Sometimes they abbreviate it with if. Did any of y'all do this? Any of y'all have professors that make you write this stuff down? I remember writing it down, and it was just like kind of like this. Didn't really understand why I wrote it down for the longest time. Anybody? Are y'all still there?
We're still here.
We're still
Alright.
here.
All right. All right. So if you ever wrote like definitions or theorems, yeah, like in algebra or in geometry, in any math class for the most part, right? This is how we define things with if and only if statements. And so if we think about like what if P then Q, that's this thing I have up here. I guess I said R, whatever, I'll call it P and Q. If P then Q. That's this sort of picture up here. That is the if then statement. And there's an only if here. So if we do an only if, going in this direction, P to Q, it goes in the opposite direction, right? P. So this is known as a conditional. This is known as a conditional. If we put them together, keep doing that. It's like one or another minus one. This is known as a biconditional. This is actually how we like start producing definitions of things. And if we look and that's basically like why it's a defining things, right? If they are both the same thing, it'll be true. If they're both true, then it's true. If they're both false, then it's true. It's when they don't match up when we start throwing them out. And so this is sort of how we start defining objects. Is with the biconditional sort of relationship. We basically take a conditional and we butt it together with another conditional going the other way, right?